Hello everyone. Today we are going to start the new topic of our chapter called some basic concepts of chemistry. So today we are going to start classification of matter. It is again going to be very important. So we have already gone through what is matter is in our previous standard also and in previous classes also, like anything which have mass and have volume are called as matter. We already gone through about different state of matter, like three basic state like solid, liquid and gas, and two hypothetical state like plasma and Bose-Einstein. We discussed everything in last class. So today we are going to understand about the mixture, like classification of matter. So I'm writing here first the matter. See, matter is divided into two part, beta, two part. Okay, first one is called as pure substance. Pure substance.
And again mixture.
Yeah, pure substance. And then we have second part is called mixture. Is called mixture. Mixture again divided into two categories. Number one, first we have homogeneous mixture.
And that heterogeneous.
Homogeneous mixture. Yeah. And second one we have heterogeneous mixture. Yeah. Okay. Then pure substance are divided into two categories. First we have elements. And then we have compounds. So they are the pure one. Elements again divided into three categories. We already gone through that in previous standard. Metals. Then we have non-metals.
Metalloids.
And metalloids, yes. Then we have metalloids. So this is the flow chart for the classification of matter. So I want everyone had to like take a screenshot, then we are going to discuss them. Done everyone?
Yes.
Okay. Okay. So first we are going to discuss about the mixture, homogeneous and heterogeneous. Okay. So what is mixture is? What is mixture? Any idea?
Mixture is the solution or mixing of any two substances or more.
Yes. Any more idea? Sadab?
Physically mixing.
Physically mixing. Okay. Okay. So I'm giving you like a brief idea about the mixture. Okay. When two or more, it is 2W, two or more substance. When two or more substance are mixed together at any proportion, is called as mixture. Is called as mixture. See, proportion is not fixed, beta. Okay, you can like mix like two or more substances at any proportion, that will be the mixture. Okay, the proportion of the component is not fixed there. Suppose you have like notebooks. Yes, beta. Yes, yes.
Sir, you have homogeneous mixture, and here you're saying when mixed together at any proportion, while homogeneous means uniform.
Wait. We are going to discuss homogeneous and heterogeneous in types, beta. Okay, I will explain that also. See, mix. See, proportion is not mixed. Suppose you are going to prepare the lemon juice for you and your dad. Okay, just I'm taking example. Okay, but you want more sugar in your like juice, but your dad wants less sugar. So you will add less sugar in your dad's glass, right? And you will add more sugar in your glass. So the proportion of sugar is constant or like fixed in your like dad's glass and your glass? No, na?
No, sir.
Yeah. So that's why I'm saying the proportion is not fixed. That's why, okay, we have mentioned that point here. So when two or more substances mix together at any proportion is called as a mixture. Suppose most of the time what happens when we used to eat the food, we do require more salt, so we are adding during eating, right? But most of the people they don't. Means the proportion of salt in that particular solution is fixed? No. Is it?
No, sir.
Even in homogeneous mixture, the no, what is homogeneous? When two or more component are present in a same phase, it is called as same phase. Means you cannot identify them separately. This is called as homogeneous beta. Understood now?
Yes, sir. Thank you so much.
Okay. Yeah. So what is mixture? When two or more substances are mixed together at any proportion is called as the mixture. Okay. Now we are going to discuss about types. So mixers are divided into two types. Number one, we have homogeneous. Homogeneous mixture. Okay. So what is homogeneous mixture is? The mixture in which the mixture in which two or more component two or more component are present in same phase, okay, are called as homogeneous mixture. Understood beta? They are present in same phase. Same phase means you cannot identify them separately. So I'm writing here components of homogeneous mixture. It's H, huh? Homogeneous mixture are cannot be identified cannot be identified separately. Okay, understood? They cannot be identified separately, are called as homogeneous mixture. Example. Okay, I'm writing example here. Example number one. Okay, aqueous solution of salt and sugar. Aqueous solution of salt or sugar. Okay, is homogeneous mixture. Second example, air. See, air is a mixture of many gases like nitrogen we have, oxygen we have, carbon dioxide and many other gases. Can you identify them separately? Can you? No. Yes. So it is again the homogeneous mixture. Number three, alloys. What are alloy? Alloy are the homogeneous mixture of two or more metal or metal along with non-metal. Can we identify like in brass, copper and zinc separately? No.
No.
In steel, can you identify carbon particle and iron particle separately? No.
Okay.
Means it is again means alloys are the homogeneous mixture. Understood everyone?
Yes, sir. Sir, it basically
Yes,
means
sir.
that if we take
Okay.
5 ml of one part of the solution and another 5 ml, the concentration will be same.
We are not discussing here about concentration. We will discuss that also. See, mixture in mixture proportion is not fixed. That we already discussed. Okay, like
Yeah.
suppose you are going to prepare lemon juice or like aqueous solution of sugar for you and me. So you will
Sir,
prefer more
that's
sugar.
for two different types of things. It happens in a single phase or a single particle.
Yeah, the thing is they are present in same or single phase. Yes. Okay, they present in same phase. That means you cannot identify them separately, are homogeneous mixture. Okay?
Okay.
Understood? Okay.
Yeah.
Now we are going to discuss about heterogeneous. This is the second part.
Sir, but sir,
Okay.
if we take the air of Delhi and the air of some place like Shimla, then there will be different sir. So air might not be air.
Yeah, that's why I'm saying proportion is not fixed.
Yeah.
Like in our room, okay, in closed room we have carbon dioxide in more percentage, but in free air we have oxygen more percentage and carbon dioxide is less. That's why I am saying proportion is not fixed. That's why I told here at any proportion. Okay, proportion is not fixed. I mentioned here at any proportion. It is very important point. Whenever you are going to write or explain others, you have to mention that point at any proportion. Means proportion is not fixed here. Okay.
Okay. Yeah.
Yeah. Second one, very important. It is heterogeneous. Okay, it is just opposite of the homogeneous. The mixture in which components of, instead of two or more, you can directly write components. Okay, components of mixture are present in different phase, okay, are called as heterogeneous mixture. Very important. Now one more thing, component of mixture can be identified easily with our naked eyes. Component of mixture can be identified easily with our naked eyes. Okay, example. Okay, suppose I'm just taking example of Samarth. When Samarth was in 8th class, he used to eat sugar from the kitchen every day. Okay, everyone, am I audible?
Yes. Okay.
So the mother of Samarth was very conscious about why Samarth is eating so much of sugar every day. By he used to watch if someone is watching him or not. When no one was watching Samarth used to go on the kitchen and open that sugar box, okay, container, and he used to eat sugar most of the time in a day. One day, Samarth's mother got one idea. Okay, what idea? That tea leaf, that chai patti we used to call, that she mixed that tea leaf in the sugar box. Okay, and again, Samarth was like in a kitchen, and when he saw, oh, like he observed sugar particle like brown or whitish, and separately that tea leaf particle in the same box. Is it or not? And Samarth stops eating that sugar because tea leaf was there, and he identified them separately. So we can say the mixture of sugar and tea leaf in a box is the heterogeneous mixture because Samarth was able to identify sugar and tea leaf particles separately. Is it everyone?
Yes.
Suppose you are mixing oil and water in a transparent jar. So water have density more, so water is going to settle at the bottom and oil will going to float on it. So again, it is going to be heterogeneous mixture because you can identify them separately. Aditi was purchasing vegetables in the market in the same bag. So like brinjals are identified separately, potatoes, tomatoes, garlic, ginger, everything we can identify separately in that particular bag. Okay, so this is again heterogeneous mixture. Understood everyone?
But sir, we
Shamat?
cannot identify the compounds in them, like here glucose, there is tartaric acid. We cannot identify them, right?
Yeah. No. I'm heterogeneous mixture. See, if
Yeah,
we
yeah,
cannot identify it so it is homogeneous. If we can identify it, so it is heterogeneous.
Hydrogen.
So yeah, mixture of sand and sugar. Many example you can like provide. Second, mixture of tea leaf and sugar. Okay, so many
Instead of other
examples.
whatever.
Yeah. Okay, so I want everyone had to take a screenshot for that. Okay, so now we are going to discuss about the pure substance. So what are pure substance? Again, they may be mixture or they may be like pure atom, okay, but their proportion of the constituent particle is fixed, are called as pure substance. Okay, so I'm writing definition for that. What a pure substance? Substance in which proportion of constituent particle is fixed is fixed, okay, are called as pure substance. Are called as pure substance. Okay, now we are going to discuss about their types. So first we have compounds. Okay, first we have compounds. Like suppose I'm writing example here. If we are discussing about sodium chloride, so here the proportion of sodium and chlorine is fixed. If you are taking glucose C6H12O6, again here the constituent particle, like we have carbon, hydrogen and oxygen in any like glucose we were taking. Suppose one glucose is formed by sugar, okay, one other glucose is formed in laboratory, okay. So like we have various sources of the sugar, like glucose, their constituent particles proportion is fixed. Suppose we are taking example of water, okay, water. Suppose that water from the various sources, like the water which is formed in laboratory, the water of rain, the water from the reverse osmosis process, the water from that well or tube well, okay, water from the river or any sources, always you will identify the proportion of hydrogen and oxygen is fixed there. That's why it is called as pure compound. Understood everyone?
Yes, sir.
Okay.
Yes.
Okay, so what are pure compound, or no, sorry, compounds? Substance which have definite chemical composition are called as pure compound, you can say. Instead of like pure substance and compound, you can say pure compound also. Okay, so what are pure compound? Substance which have definite chemical composition are called as pure compounds. Understood everyone?
Yes.
Yeah, and like they, see, if they are collected from the various sources, okay, they will show the similar chemical and physical property. Okay, the thing is they have to be pure. You can collect from any source, but their component like proportion of hydrogen oxygen is fixed, and they will show like definite chemical and physical properties. Like suppose laboratory water is going to boil at 100 degrees Celsius. So rainwater, if it is pure, so again it is going to boil at 100 degrees Celsius only. So their properties will fix, they are not going to change. Understood everyone?
Yes, sir.
Yes.
Yes, sir.
Okay. So now we have, after pure compound, we have elements. Okay, what are elements? you have like studying since like 3-4 previous standard. So what are elements? Yes.
Elements are the basic building blocks of any substance.
Okay.
Sir,
What?
they only have one type of atom in them.
Okay. What else?
They're a group of atoms.
Group of atoms. Elements are group of atoms.
So they are singular.
Okay. See, pure substance which okay, my voice was disconnected, no?
Yes.
Okay, I was getting call, that's why. Okay, elements which cannot divided or broken down into simpler substance by any ordinary chemical means or physical means are called as element. Are called as elements. I'm writing definition first and then we'll discuss. Elements are the pure substance. Elements are the pure substance or substance. I'm writing pure also. Pure substance which cannot be broken down into simpler substance, simpler form, you can say also simple form by any ordinary physical or chemical means. Chemical means are called as elements. Okay, like suppose we have 118 elements in our periodic table. We cannot break down them by the simple physical or chemical means. In order to break them, we had to like very uh, different condition for them. Suppose we are going to like bombard neutrons on their nucleus. Suppose we are having uranium 235. Okay, when we are like firing one neutron in its nucleus, so uranium is going to accept one neutron in its nucleus, and its atomic mass is going to increase by 1. Is it or not? So let me explain you the process over here. Suppose we have uranium 235. One neutron we have and we are going to fire on uranium. So uranium will accept that neutron. So its uranium's atomic mass is going to increase and it will be 236, right? Here we are writing 235 and its atomic number is 92. 92. So its atomic mass is going to increase or not?
Yes.
Yeah. And that isotope of uranium is very unstable and it breaks down into two parts. One is called krypton and other is called barium. Okay, so see here, this reaction is not ordinary. This is the nuclear reaction. It is not ordinary. Okay, and we are saying the ordinary physical and chemical means they cannot be broken down into the simpler form. But here uranium is broken down into two simpler elements like krypton and barium, but this process is not ordinary. Understood?
Yes.
Yes.
Everyone. So elements are the substance which cannot be broken down into simpler form by any ordinary physical or chemical means are called as elements. Okay, and again we have already gone through in previous standard. Elements are of three types. One are called metals, other we have non-metals, and last but not the least we have metalloids. In our modern periodic table we have total 94 metals, 17 non-metals, and 7 we have metalloids. And we already discussed in previous standard, elements having tendency to lose electron are called as metal and they are electropositive in nature. Non-metals are electronegative in nature, and metalloid shows properties between of both, we can say, metal and non-metals. Okay, so this is all about the pure substance. I want again everyone had to take a screenshot for that.